What if I told you that the biggest solar storm in 20 years has hit the Earth and we were very lucky? Despite this good news, astronomers are still on alert because the most violent solar cycle in a long time is not over yet. A gigantic sunspot has formed, similar to the one that caused a catastrophe in the USA 200 years ago. If the spot continues to grow, things could get tight for us. Either the storms still to come will bring us colorful auroras, or they will paralyze all our communications and power grids within minutes. Elon Musk has expressed his concern. On May 11, 2024, the SpaceX boss posted an alarming graphic showing how much pressure the last solar storm had put on Musk's satellite system. A violent stream of particles from the sun had hit Musk's Starlink satellites and driven up the measured values for functionality and load. The satellite's protection mechanisms were stretched to the limit, and an even more violent storm could completely overwhelm or even destroy the technology. That would, of course, be a nightmare. Not only would regional internet and mobile networks on Earth fail, but it would also be a disaster if dozens or hundreds of junk satellites were floating in space. Musk went on to post that we have been lucky once again, but he and his company are alarmed. Starlink satellites are among the most modern in the world, and it's a first test of how much the marvels from SpaceX can actually withstand. Solar storms are considered the underestimated danger of the 21st century. Experts have long been warning of the one big storm that is coming and that will put our entire civilization to the test. Particle streams that hit the Earth's magnetic field from the sun not only give us beautiful light shows, which we usually only see at the poles and know as auroras. What many people don't know is that the beautiful auroras are produced by streams of particles from the sun. The electromagnetically charged particles are captured by the Earth's magnetic field and then trapped in magnetic deposits above the two poles. In this way, the Earth's magnetic field normally prevents the particles from penetrating into the deeper layers of the atmosphere. At the poles, the particles are moved up and down in the deposit until they have lost their charge. We see this as the colorful light shows. The strongest solar storm to hit us in 20 years caused auroras, or polar lights, to be seen much further south in the northern hemisphere and in the southern hemisphere. People north of the polar region saw magnificent colors in the night sky. Auroras shimmer in green, purple, blue, orange, and sometimes red. If we believe the experts' forecasts, the exceptionally strong storms will continue for quite some time. Then we'll be able to enjoy the colorful spectacle again, or we'll be in serious trouble. The most violent flares for 20 years. It's scary to think that the sun can unleash a gigantic stream of particles at any time, which will hit our Earth within 20 or 30 minutes. As soon as the particle bombardment is released, it has already reached us. That is the dangerous thing about these storms. The preparation time for a really violent flare is short. The streams are triggered by sunspots or coronal mass ejections. Sunspots are temporary areas on the surface of the sun that appear darker than their surroundings due to their lower temperature. They are caused by strong magnetic activity inside the sun, which suppresses convection processes. This causes the temperature to drop, and extreme forces form in the affected areas. These can then lead to the release of large amounts of energy in one go and blow myriads of particles into space in a matter of seconds. A particular focus is currently on a sunspot group called AR3664, where 16 smaller sunspots have come together to form a large eclipse. At the beginning of May 2024, the spot was so large that it was visible from Earth with the protection of solar eclipse glasses. The spot is 15 times larger than our globe and was responsible for the intense solar storms that distressed Elon Musk's satellites, among others. AR3664 has produced 75 M-class and 10 X-class flares in just 1 week. M-class flares are in the medium range, and X-class flares are among the strongest. On May 3, 2024, an X1.6 flare was observed, followed by several more X-class flares, including an intense X4.5 flare. These eruptions are significant, as they not only release enormous amounts of particles that can reach Earth within minutes but can also cause much larger coronal mass ejections. We are currently in a solar cycle that lasts about 11 years, and we are at the peak of solar activity. This 11-year cycle is characterized by extreme and sometimes difficult-to-predict fluctuations in solar activity. During the solar maximum, we can expect the most violent X-class flares, and we can expect the one big storm that experts fear. The current maximum also worries scientists because it has occurred earlier than expected, so something is wrong with the Sun. Based on the recent activity of AR 3664, it is even suspected that the Sun's magnetic fields are reversing, which could lead to even more frequent and intense geomagnetic storms. The last significant solar storms, known as the Halloween storms of 2003, reached G5 intensity and caused worldwide disruption to power supplies and satellite communications. Auroras were even visible in regions such as Florida and Mexico. Forecasts for the coming weeks indicate that AR 3664 could send us storms of 2003 intensity, so we need to be prepared. Right now, the spot is pointing away from Earth, and we are safe for a while, but soon AR 3664 will rotate back towards Earth, and that could bring another season of intense geomagnetic storms. For now, we need to monitor this sunspot group closely to minimize the potential impact on Earth and its technological infrastructures. Sparks flew from telegraph poles in 1859. Imagine looking up at the sky in the morning, and it seems to be on fire. This is what people in the USA experienced around 1859. The Carrington event is the strongest documented solar storm in modern history. It occurred from August 28 to September 2, 1859, and was named after the British astronomer Richard Carrington. On the morning of September 1, 1859, Carrington and his colleague Richard Hodgson independently observed an unusually bright flash of white light on the surface of the Sun. This was probably the first time that astronomers had witnessed a so-called solar flare. This solar flare was part of an enormous sunspot region that triggered strong geomagnetic storm activity. The coronal mass ejection reached Earth within about 17.6 hours. This rapid arrival was due to the enormous speed and energy of the ejection. People all over the world saw the effects of the extraordinary geomagnetic storms. They produced spectacular auroras that were seen in Europe, North America, and even as far away as Cuba and Hawaii. In the southern hemisphere, the southern lights shone as far as Santiago, Chile, and Queensland in Australia. In the USA, the Carrington event caused considerable disruption to the telegraph infrastructure, which was the most advanced means of communication at the time. Telegraph systems failed. Sparks flew from telegraph wires, and the surrounding area caught fire. The consequences were fires and damage to telegraph equipment, which was dramatic at the time. Many telegraph systems were destroyed by the charges, while others ran completely without any additional power supply. The energy from the solar storm was enough to supply some devices with sufficient power. The effects on the technology of 1859 were dramatic but minor compared to the risks of today's civilization. If a similar event had occurred today, the consequences for our thoroughly technologically dependent society would be fatal. Satellites, power grids, GPS systems, and communication infrastructures would be severely compromised, and it's estimated that the economic damage could run into the trillions of dollars. If such a storm hits us within a very short space of time, the failure of navigation and control systems could cause major accidents and disasters, particularly in air traffic and shipping. Particle streams, vital and, at the same time, extremely dangerous. The Carrington event shows very well that solar storms and coronal mass ejections are actually harmless. They do not harm us humans and do not destroy anything in nature. It's only our technology that causes problems. The Earth has probably already experienced thousands of these violent storms. Solar storms occur practically all the time due to the intense magnetic activity that is quite normal on the surface of the Sun. These activities lead to the somewhat more harmless solar flares and the larger coronal mass ejections. A flare appears as a sudden bright eruption of energy on the Sun, resulting from the release of magnetic energy in the Sun's atmosphere. This energy consists of light and high-energy particles and can be released as a small burst within a few minutes, or such a flare can drift out into space for hours. Coronal mass ejections, or CMEs for short, on the other hand, eject large clouds of magnetized plasma. Normally, such ejections are rather slow, and they reach the Earth within a few hours or days. In 1859, the energy of the CME was so great that the plasma cloud reached the Earth in less than 20 minutes, so this was truly an exceptional event. And yet, We must expect such an unusual stream of particles to hit us again at any time. That can be worrying. Particle streams can be dangerous for us, but they are actually good. The streams, consisting of protons, electrons, and heavy ions, are practically omnipresent. They contribute to space weather, carry energy through space, help shape our climate, and the virtually continuous flow of charged particles emanating from the Sun's outer atmosphere forms the heliosphere that envelops us and protects the solar system from interstellar cosmic rays. Without these particles, we would be unprotected from the intense radiation of the cosmos, and life would very probably not be possible. If we want to protect ourselves from this actually harmless and even good natural phenomenon, we need to safeguard and improve our technologies. Is it possible to protect against solar storms? Did you know that all modern satellites are built to be extra resistant to space storms and flares? Modern satellites and power grids are already designed to remain resilient to strong electromagnetic fluctuations. However, this only applies to a small proportion of satellites and power lines so far. Many networks and devices are still outdated and are more likely to give way in the event of a strong storm. Governments around the world are therefore also concerned and are taking the threat seriously. Electricity companies are constantly working on new technologies to protect their grids, substations, and power plants as much as possible. A prominent example of a storm that paralyzed an entire power supply is the geomagnetic storm of 1989, which hit the region in Canada in particular and paralyzed the entire power supply there for a whole day. Satellites orbiting the Earth are the most exposed to the Sun's high-energy particles. The same also applies to the International Space Station, ISS, and the spacecraft that supply it. The particles can damage electronic components and lead to serious malfunctions in space. Even minor accidents or failures can quickly become life-threatening, which is why Musk and NASA fear storms like these.